So far we are discussed about the construction. Next one is a working. So construction we were discussed about MOSFET construction, and another one is a IGBT construction we were discussed. Okay, then next one is a working. Working about that one, very simple about that one. First we are going to give the input source. Input source means gate. So gate is a positive terminal you will going to apply, and with respect to the minus, so minus I will going to give the power supply to that gate with respect to the body. Once I will going to give the power supply to that body means this is a capacitance. Okay, in the capacitance is a plus. Okay, plus. Okay, here is a plus is a form, and here is a minus is a form. So minus is a form. Okay, that's all. This is a minus is a form. Okay, so where I am going to apply. So I am going to apply for the gate with respect to the body. Body means source. So I will going to give the power supply. If I will going to give the power supply means, so due to the SiO2 water layer, here is a plus is form and minus is form. So what is the voltage you are going to apply? I am going to apply for the 2 voltage. If I am going to apply the 2 voltage means the in current layer is here. Okay, here only. If I will going to apply for that one, I will going to apply pink color. Yes. Okay. If I will going to apply for that 4 voltage, if I will going to apply 4 voltage, the in current layer is a more negative voltage. Okay, due to the more negative voltage, this layer is pushed to here. So the layer is coming to here. Then I will going to increase that one input side. So high voltage. So 5 voltage I will going to apply for that one. Get to the source. I will get to the source or body. I will going to apply. What will happen? Okay, here is a further negative voltage. The in current layer is coming. That's all. So what is the applying the voltage base? The in current layer is moving. So based on the movement of the in current layer, okay, based on the movement of the in current, okay, based on the voltage, the in current layer is moving. Based on the, okay, voltage base, the in current layer is moving on the P layer. It will going to move from this to this, either lightly open or heavily open, or lightly open or fully open. Okay, this is just to open the path. Okay, open the path. Why it is open the path? Here I will going to give the power supply. So what is the power supply? So through that one load. Okay, this is nothing but it's a switch. That's why. Okay, so through the load, lamp load or LED load, I will going to take it and give the power supply, and the power supply to source. If I am going to give the power supply, what will happen? The source immediately I will going to give for that one, it's a 2 voltage or 5 voltage. Immediately the current is a flow. The current is a flow from drain to the source. It is a flow. Once the current is a flow from drain to the source, then only what will happen? The circuit is closed. So whether this it's the in current is a lightly open or heavily open, it's a fully open means what will happen? The drain current is there. It is freely flow. It will going to freely flow to that source. That's all. So like it is a circuit is closed. So it is a freely flow. Okay. So this is about the working of the MOSFET as well as IGBT. Both also working the same. Okay. Both also working is same. So only one thing, IGBT means the N plus layer is replaced into the P plus layer, and this is a one point, and this is a drain is replaced into the collector, and source is replaced into the emitter. So coming to this one, so drain is replaced into the collector, and I will going to change the color. Okay, drain is replaced into the collector, and then source is replaced into the emitter. Okay, and another one is a P plus layer. So where is a P? Then N is replaced into the P plus. So that's all. So this is the only changes about that MOSFET into the IGBT. MOSFET into the IGBT. So working of that one is over, and the characteristics is over. Okay, that's all about you will going to learn. So and one more things you will going to tell about that one. So path you will going to write about the path. So once you will going to, this is a MOSFET. Okay, once you will going to give the gate terminal input voltage, you will going to apply gate to the source. Once you will going to apply, what will happen? So here is a plus terminal and the minus terminal is formed. Okay, form the minus terminal. Once the minus terminal is formed, these two is connected. I mean the breakdown. I mean the gate is the line is open. The line is open. Similarly, this side also this line is open. Which line? So so this line is open. This line is open. Why this line is open? So once you will going to give the step number 1. So this is step number 1. So once I will going to give the power supply to this place. So once I will going to give the power supply. This is step number 1. Okay, input power supply is applied. So here is a plus terminal and a minus terminal is created. Okay, and this is a minus and a plus is there. Then this is a point is open. Okay, then step number 2. So apply the voltage to the VDS. So VDS. So drain to the source, you will going to apply the voltage. Through the load, you will going to apply. So power is a flow from the drain terminal, it is enter. So N plus n minus, and p to that one directly it is connected to that one, and connected to the source to the load to the closed circuit. So I will repeat again: source to the drain to the n plus, n minus, and then here is a p. So through the p layer, then the p layer it is directly, it is open this point and connected to the source to the load to the negative. So like you will going to write the path. So this is about that. One more point, you will going to write the working of the MOSFET as well as IGBT. Okay, fine. Yeah, so analogy easy, simple to understand. Okay, so far we have discussed this is the things only. So this is a tap. So the tap lightly pressed means incurrent layer is a 50% open. Suppose fully present, the incurrent layer is a fully open. So water is coming from input to output. Okay, then next one, when you will going to do for that practically, you will going to make the product, you will going to make it for IRFZ44, one of the IC that is called the MOSFET IC. You can take it and connected one resistance and one LED. You will going to connect it for output side. You will going to make the circuits. You will going to make the circuit. You will going to make it. Okay, this is called the power circuits. So maximum you will going to apply the voltage is 50 voltage. You just now we were seeing about that one data sheet. The data sheet is accepted at IRFZ44 is a 50 voltage. So you will going to apply for that 50 voltage of the load you will going to use. Even you will going to make the, you will going to use for that one small fan also you can use it, DC fan. Okay, DC power supply you are applying. So 50 volt fan you will going to use. So 50 voltage fan you will going to connect it. Okay, that's all. Either you can use the fan, or yeah, you will going to use the resistance, or this is also resistance. So you will go to whatever you want, you can use. This is these two is act as the load. These two is act as the load only. Okay. Okay. This is called a power circuit. This is the portion is called a power circuits. So you need to trigger. How to trigger? So triggering is very simple. You need to trigger with the help of the, so with the help of the resistance triggering. Okay, so we will going to give that one. Okay, source. Okay, here is a gate terminal and the source terminal. Between here, so one resistance is connected, and here you will going to give the power supply, and the power supply is connected to the source. So like you will going to connect it, either source or the body you can connect it. This is a triggering. This is a method is called a triggering. So once you will going to give that one, it will going to trigger. Okay, the switch is closed. Otherwise, the switch is not closed. Okay, for I will going to show you. See, so I will going to connect the source. Okay, I will going to connect the power supply. See, plus terminal to that one, limit the current and connected to the gate terminal. Okay, source is already connected to the minus. Source is already connected to the minus. So once you have make the connection, what will happen? You will going to control on, turn on, control turn on is happen. So it's a switch is closed. The switch is closed. So switch is closed. Switch is closed. So now the power is a flow, then LED to that one closed. LED is a glow now. LED is a glowing. It will going to glow. Okay. Then once you will going to remove the connections, and gate is connected to the minus. Okay, once you will going to remove the power supply on the gate side and connected to that one ground. If you're going to connect it, means what will happen? Control turn off. Control turn off. It will going to happen. Control turn off. It's an on off switch. Once you will going to give the power supply, even you will going to disconnect it, it is controlled on. Keep on, controlled on. Once I will going to make the circuits, once I can make the on the circuits, now its path is closed. Yes, the path is closed. Up to what? So even you will going to disconnect it, the path is still it's closed. That one we were discussing in the yesterday video. In the video you saw about that one. Okay, once you will going to, it's on off switch. Once on, the switch is on. Then how to turn off the switch? So I need to turn off. Then you will going to connect this gate terminal, connected to the source terminal. Then the switch is open. So that is like that one. So this is about that. Okay, control turn on and control turn off. So next one. Okay, yeah, switching switching characteristics or dynamic characteristics. So dynamic characteristics, it consists of, you have see that how the park. Okay, so who all are there in the park? Just we will going to explain the picture in the park. So that is called a dynamic characteristics. So similarly you will going to start to see that one, these pictures. So I will going to give that pulse. Okay, once I will going to give the pulse, how the reaction is happening inside. So what about the output current and output of the output of the current and the input of the voltage? How it is the reactions? So turn on is include for the delay time plus rise time. During the delay time, what is there? So the input voltage start to rise from 0 to threshold. Then output current is 0, after threshold only the output current is increase. Yes, that one we are seeing about that one transfer characteristics. After threshold, then only what will happen, after threshold only the output current is increase. So before that, this is output current versus the input voltage, output current versus the input voltage. So before the threshold means the output current is 0. So before the threshold, okay, output current is 0. Then once cross the threshold, then output current is start to increase. Okay, then so that is called a rise time. Then rise time means a threshold to that peak. So it's a rise. Then current is a flow constant. Then after that, what happened, once it is reached a maximum value of that one input voltage, then what will happen, output current is saturated. Similarly, turn off. The turn off is consist of that one delay fall time and fall time. Delay fall time and fall time. So during the delay fall time, what happens is the output current is maintained. So during the fall time, then output current is start to decrease. Just to see the picture and start to answer. That's all. The same thing we had explained, okay, in the statements, and then we were discussed about the recap. Okay, what are the timing included, and look it once on that once. These are the recap we were done already. So you look once. Then we go ahead on the term IGBT. So IGBT is a combination of that BJT and the MOSFET. It is called IGBT. The input side is a MOSFET is used. See that the input side is MOSFET is used. That's why it is a voltage control device. And output is a BJT. Then yeah. So it is inside of the inside of the construction of that. This is developed IGBT, developed symbol, and then IGBT. See plus, okay, MOSFET plus BJT, it is equal to IGBT. And you have see that output characteristics, same output current versus the output voltage. You will going to draw. This is the different values of the input voltage. You will going to draw. So this is same output characteristics. Okay, then construction of MOSFET we were discussed. Then construction of that IGBT, when you have go here, then N plus layer is replaced into the P plus layer. Same symbol, same arrow mark, same as it is remaining is same ditto. Fine. The next one, yeah, it is there are two layers. Here is a junction. There are two junction 1, junction 2. Junction 1 is a forward bias, and the junction 2 is a reverse bias. So in that P plus layer, you can call it as a injection layer. N minus layer is called a drift layer. Yeah, static characteristics. When you have see as similar to the MOSFET, the static characteristics. This side is a triggering circuit. This side is a power circuits. Okay, here you will going to give that one minimum voltage, threshold voltage. Once they cross the threshold voltage, then output current is increase. Then once it is a threshold voltage, for example 2 voltage, after that what will happen, the switch is closed. Yes, then output current is increased. Then before threshold voltage, before the 2 voltage, the switch is it is a open only, off only. Then output current versus the output voltage, you will going to draw about the characteristics, that is called the output characteristics. Variation with the different input voltage, 2 voltage, 2.5 voltage, 3 voltage, 3.5 voltage, and then I will going to apply the 5 voltage. Then what about reactions? So this is about the different variations you will going to do on the laboratory. So transfers, so far we have discussed about that one. Yes, the next one is the dynamic characteristics of that IGBT. Same as similar to that park, you have what are they doing, just you will going to start to explain about that one, that is called the dynamic characteristics. Similarly, you have see about that one, this is a diagram of that IGBT. Just on time you have look, delay time plus rise time, So what about the delay time? So delay time of the output current and the output voltage, what about that one? Similarly, input voltage, it will going to rise, it will going to increase up to the threshold, and output current is before threshold, it's 0 only, 0 point very less, below 0 only. Okay, once cross the threshold value, what will happen, that is called a rise time. So threshold to rising, so increase, that is called a rise time. During the rise time, output current is increase, as similar, everything is similar, as similar. Fine. Similarly, output turn off side also, delay time, fall time 1 and fall time 2. So you will going to just see the diagram and explain. So this is about the dynamic characteristics of the IGBT.